Hi, my name's Curtis Greshall. I work for Super Sky Products, and we're contracted by Innovo to produce the skylights for the WMATA escalator canopies. We're looking at Tenleytown Station here on the screen. I've just chosen that one as a first run through to illustrate some geometry questions to coordinate between the skylight and the steel structure. This little chart here is the basis of all the layout. It defines this L curve at the top of the glass and the T curve at the top of the glass. The T curve exists in this plumb plane, or radius 0, and then it turns a partial degree, I think 0.72 degrees to get radius 1, turns another 0.72 to get radius 2, and so on to get 3, 4, 5, 6. I tend to make a radius 7 to locate that last one because it's also a typical space. The inclination of the skylight to the right isn't shown on this drawing, but on this page 201 you'll see it says glass panels are horizontal. So in this case, this glass is 90 degrees to the plumb plane we saw before. And the glass here is turned some partial degree off to the glass, and then a partial degree on either side of all these radial lines. So this detail is an oddball. This is flat, and this glass does a turn. Do not think this can be flat like this one. I think it should have a turn, like as if there was really a radius here. But we could discuss that. It's just a matter of knowing what's being built by the steel to work that out. So let's go back to this chart with the dimensions. These are all at the glass. They give the radius for the steel, but then they don't always give a lot of other numbers. They leave it to work back from the glass dimensions. This plan gives dimensions at the glass on the eyebrow, on both ends, and the typical bay. But the steel below would all be different dimensions. While they would match here, they'd be slightly smaller at the typical and slightly smaller at the downhill eyebrow. And I wanted to kind of go over this to start coordinating with the steel now so that their drawings and our drawings will match when they come together. So let's look at the wireframe real quick. And we'll go to Tenleytown. Here's the transverse section, and this is the radius at the glass. This is the radius at the steel. If I measure from here to here, 2'11", and if I measure at the steel, we're going to get 2'10" and 5/16. It's quite a difference. So we just want to make sure we don't want the steel to be made 2'11" because they use the glass dimension. They have to work back to get that number. Over here on the longitudinal curve, again, you've got the glass arch and the steel. There's that 0.72 degrees between the radial lines. So here's your plumb plane, and then radius 1, 2, 3, 4, 5, 6, and the imaginary 7 to help define the end. And we're 80 inches at the glass, and 79 and 15/16. So we shrink a 16th at the apex when we get down to the steel. So those are important things to coordinate, that the glass is one dimension and the steel is another. That's the radius from that page. And when we developed it to get out to three-dimensional, I've created the skylight geometry on this side in a wireframe. And then I went and I started to build the steel geometry on the left. And you can see they kind of follow the same patterns, but there is that wedging as you come in. So let's look at it from the front. And you can see it keeps, if you would go all the way to the end, maybe it's better to see here. Here's the wedge, and if you took it to the extreme, it would all go to 0. And that happens here as well. Now, on this end, where we're horizontal, the dimension from the skylight work point down to the steel is just a vertical drop. So it's the same at the steel as it is at the glass, but only because this one does not follow the same angles as the other one. See if I do, so we're 90, and on this side 89 and 38 minutes. So that's kind of an uneven detail, but that lets this baby easier to project that the steel would be the same as the glass. It would not be true here, as we illustrated before. And when you get to this end, I'm not sure how the layout for this should work. I assume that this bay is another bay typical to this one, and we have a radial 7. And take this, and I project down to the steel on that same radial line, which is shrinking it about a 1/16 here and maybe a little less than a 1/16 there. Now, you can't really go vertical because that would change things too much. It might be possible to go square to this edge on this one side, but you're still shrinking over on this one. So I don't know what the preference is. It can't be the same on this end as this end. Even if we would make the outside edges match, that edge would be different. So I tend to think make this one just be the same tipped in angles on both edges. That's the first thing to coordinate there. The second point to coordinate is these corners here have always been a dimensional problem. Very understandable, I might add. Let's look at those steel tubes. These tubes here, the eyebrows, are twisted and turned in two directions, or they're not a simple arch like these are. These are just rolled tubes. And the ones going down the length, the LBs, they're straight tubes. That's all pretty understandable to work with. But these guys on the curb are pretty crazy. And if you look at them, you'll see they're tipped and rolled at the same time, which is hard to understand how they do it. I can use funny commands in a computer, but I don't think anybody's shop does that same stuff. And here's the eyebrow beam is even more extreme. So my second question is, what can be held at this dimension? From that work point right here to this work point here. I'd like the steel guys to give us that number that they can hold, and we'll make the skylight match it. Now, obviously, this is the design intent. We don't want to vary from it too much. But if it's not going to happen, I think maybe we should bring it up and adjust that dimension to something that's doable, so that things work when it's installed. So that's question number 2. Number 1 was what to do on the low side for those steel dimensions. Number 2 is what to do at these two corners. As for what's a controllable dimension. And I think that's really about it for coordination. The rest of it is always worked out pretty well. I'd just like to find out what we're going to do to position these eyebrows. And the skylight, we can't field modify the skylight, but we can design the skylight to fit the steel with relatively little trouble. Field modifications won't work. The glass is heat treated, so you can't cut it. The frame is compound miters or compound miters with coping, and there's no way to do any of that in the field. So the skylight frame comes completely fabricated, knocked down, bolts together on site. We can build connections that have some adjustment, plus or minus a ½ inch. But that's as much as you're going to get out of a skylight frame. So I think that was it. I just wanted to start a discussion to coordinate these tolerances or layout coordination for the geometry, given that there's not really corresponding numbers in the package for the steel at these points. That seemed like that left it as a pretty open issue, and without some discussion we could drift apart. So I wait to hear back so we can coordinate that, and thank you very much.